Our next time-dependent forecasting method would be exponential smoothing. And this is a little bit different than the weighted averages. It is a form of the weighted moving average, but we set it up so the weights decline exponentially. And what this is going to do is going to weight the most recent data heaviest. And using an exponential form, as you can see in this curve here, so this is in the form of a times e to the negative x, whatever our weight is. And the let's try that again. The exponential smoothing method really does require a smoothing constant. And that's typically between 0 and 1. Sorry, that is between 0 and 1. It's typically 0.1 to 0.3. And I almost said 10 because this is basically, we're looking at 0 to 100%. And so typically that smoothing constant is 10 to 30%, which is how much the previous month is weighted. So a constant of 0.3 means that we're going to be taking, as part of our entire forecast, 30% of the weight is going to be on the last month, and it's going to decline exponentially past that. So let's take a look at the equation. And so we're going to forecast for the next period. So that's ft plus 1 is our equation. So what we're going to do is we're going to take whatever the forecast for this period was, which is f sub t, and then we're going to add to that alpha, which is our smoothing constant, times the difference between this period's demand and the forecasted period that we've got. So we've got this period's forecast in two parts of this equation. And so it's really baked in. So what we have, this AT minus FT, is really how much error was in our forecast. And so we're going to take how much error is in our forecast, we're going to multiply that by our smoothing constant, we're going to add that back to this period's forecast and say, okay, that's what my next period's forecast is. So I had forecasted it, I was off by a little bit, so we'll say we'll take some percentage to it, we're going to add it back into this period's forecast, and that's going to give us what next period's forecast is. What's nice about this is you really only need this period's forecast and the actual demand to compute things, because all of the old data is kind of baked in to our forecast for this period, because now we have all of these forecasting errors in. In a couple slides I'll talk about, or I'll show some examples of how alpha influences the forecast, and we can see the full blown out equation. But let's actually take a look at using this in an example. So let's say we're building Mustangs, and I actually should have changed this because I don't really like Mustangs. I would have put Jeeps or Corvettes or something in here. But so the predicted demand is 142 Ford Mustangs. The actual demand for this period would have been 153 Mustangs, and then our smoothing constant we're going to say is 0.2. So using this data, I want to know what my forecast for next month should be. So how do I calculate that out? So I take it, and my forecast for the next period is going to be this period's forecast, which was 142. Follow this arrow here and plug that in. Plus our smoothing constant, so our alpha is 0.2, times the actual demand, which was 143, and then our predicted demand. And so as we take a look at that, so if I take a look at that, so all of this right here, I was off by 11. Since I was off by 11 cars, then I went, okay, well, my smoothing constant's 0.2. And so I needed 11 more cars than I actually made, so we're going to use our smoothing constant of 0.2. So next month, we're going to increase production to go up by 2.2. And so basically we're going to say we need 144 cars instead of the 142 that we initially demanded. So why use this method as opposed to the other ones? Well, the exponential smoothing, especially if we've got things set up with our smoothing constant, we can take a look at things, and then huge spikes in either direction, we don't have to try to chase that spike completely down. We can sit there and kind of just slowly but surely level everything off and follow these small fluctuations as we go. Now, I did promise that we'd look at the effects of the smoothing constant, so let's do that. So let's say that we're looking at that same data, and as we increase alpha, the older data becomes less significant, because if we're looking at it, as I said, the alpha really is looking at a percentage. So an alpha of 0.1, we're looking at the data, and we're really taking we're weighting the previous period by about 10%. So if I look at that exponential smoothing formula and actually rewrite it out where I'm not using, because remember, in that FT, we have everything baked in from the previous. If I actually expand that out and do a series expansion with it, what it really is going, okay, well, it's alpha times the demand from last period plus alpha times 1 minus alpha, the demand for 2 periods ago, plus alpha 1 minus alpha squared, the demand 3 periods ago, on and on and on into infinity. And so if I look at, if my alpha is 10, that means that 10% of my weight comes from the previous period, and then as I start working things down, 2 periods ago, 9% of my forecast will come from that. 3 periods ago, 8.1% will come from that. And as it slowly starts to decay. And so as we go along, the older data is still there. And it's still, and as you can see at 10%, the data, we're dropping down by about 1% of time. So once you get out 11 periods, the data really doesn't matter anymore. So what happens if I kick that up to 50%? Well, that means that the last period's data is 50% of the forecast for the new one. 2 periods ago is 25%. 3 periods ago will be 12.5%. And 4 periods ago will end up being 6. And so within, instead of 11 months, within about 4 months or so, the data, 4 or 5 months, the data isn't going to matter as much anymore. So if I kick that up to 90%, well, that means that almost all of my forecast is going to come from what's happened the last period. It almost makes it kind of that naive approach where this month's demand is going to be the same as last month's demand, but this is a little bit better because it does weigh a little bit of things in. But if you look at it, 90% of that forecast is being determined by last month, 9% is being done by the month after that. And so realistically, the only data that's going to matter if you've got an alpha of 90% of an alpha value of 0.9 is just the last 2 months. Really, anything 3 months and later really is going to have no effect, no appreciable effect on that forecast. So what does that mean? Well, the implications mean that as alpha increases, we're going to see larger fluctuations in the forecast due to more influence being placed on the most recent period. And let's take a look at my car example here. I do apologize if you guys heard my dog barking. She's trying to protect us from the evils of whatever is on the front lawn. But anyway, let's go back to my car example and take a look at how that would change based on different demands. So if I look at, and we're doing demands by quarter, if this is my curve of my actual demand, and once again, we got this great red-green thing going on. So this curve right here is my red curve. That's my alpha of 0.1. And so what does that mean? That means that the previous period is going to have 10% influence on the new demand. 2 periods ago is going to have that 9%, and as we go along, and you can see it's a relatively stable curve. As this demand spikes up between quarters 4 through 6, you can see it slowly start to come up, but it doesn't really spike up with things because it's holding things kind of steady because we're doing an average over, like I said, almost a year of worth of data. Now, as we look at alpha of 0.5, so that's really weighting 50% of our new forecast is going to be based on what happened in the last month, 25% 2 months ago, 12.5% 3 months ago. You can see this one here as the green line as it goes along this curve here. It does a better job of catching up with the demand here, but then, it has to catch up with the drop-off. Which one is right? Should we be using alpha of 10%, alpha of 50%? I mean, that's really going to come down to, as you look at what data is going on, and as we said earlier, it's really going to be based on experience and kind of a guess of what you want to use. And so basically we want to choose high values of alpha when the underlying average is likely to change. And as I pointed out here, as you can see, this popped up quite fiercely. This followed it much better than our 10%. And then on the other end, we're going to keep a low value of alpha when those underlying averages are kind of stable. Because as you can see, once again, taking a look at this one at alpha 0.1, we had this huge spike in demand. It just slowly went up a little bit. It didn't chase that demand like the alpha of 0.5 did. And once again, it's going to come down to intuition and kind of a sophisticated wild-ass guess. And once again, that's not just a guess. That's a guess based on your experience and knowledge.